Thank you for coming and being here, everyone. I'm Ryan Blue. I'm one of the original authors of Apache Iceberg, so a lot of the really hard bugs in there that we haven't been able to get rid of yet, those are all my fault, so sorry about that. I'm also responsible for bugs in Spark, Avro, and Parquet, some real nasty ones in Parquet due to timestamp issues, which is something I think no one gets right the second time. So, all right, so I'm going to talk. We talked a lot about these concepts already, but I'm going to point out sort of what I think about when I think about data architecture right now, and I call it a bit of a quiet revolution. Um, so here's the plan. Oh, next slide. Okay. There. Oh. Yep. Okay. There we go. So I have a pretty brief agenda here. Today's talk is extra fun because I didn't submit an abstract on time and they told me what I was talking about. So it's a really great opportunity to think about the problem differently and think about, basically look back and then look forward. So what I'm going to talk about is a brief history of me, my background, and where sort of my lens on the data space. Then we're going to talk about design principles that I think have really held up and contributed to what Iceberg is today. We're also going to talk about when this thing sort of took off on its own. And then I'm going to make some wild predictions about the future of data architecture that we can all collectively laugh at in 10 years. So I hope that sounds like fun. Let's go for it. So this is about Excel, but this really captures, I feel like, the ethos of the Hadoop movement. It was a whole bunch of us distributed systems engineers going off and thinking, who needs databases anymore? And then we realized that that was an incredibly bad idea. And why didn't someone just tell us this? I think Stonebreaker actually did. But we eventually realized that we had built up the Hadoop ecosystem without a lot of the foundation that we actually needed. So I came from the distributed systems space. I viewed this as a distributed systems problem, much like everyone else, and made some mistakes along the way. Iceberg is probably best described as an attempt to fix a lot of those mistakes that were just hard, that we never really got around to. I should also point out that my background is not in the data warehouse world or even the database world, so I'm still learning a lot of this as well. Especially, I did not like databases going through college. That was not my thing. But now I find them, sort of fascinating. A little bit of compilers, a little bit of, file formats. It's a lot of fun. All right. So that's my background. That is how I see the space. I'm coming very much from the Hadoop ecosystem, but I've learned a lot about data warehouses. So let's take a look. When we started the Iceberg project, we really wanted to basically fix Hadoop. We had so many challenges from lack of transaction semantics, a lot of people coming to us constantly saying, like, I made this change and now nothing works. And we really had to solve this. But we didn't want to solve it in a way that was specific to Netflix or that was not lasting. So I think that we approached this with some good intent in mind, and hopefully you'll agree that these things paid off. So first of all, we wanted to be open source. Now, this was at the time more of an assumption than anything else. But I think with any of these principles, it's good to not just look at the positive. We don't want these to be platitudes like, oh, open source is important because everyone gets to participate. We actually want to look at the negatives, right? What are we trading off when we look at these principles? So open source is actually a story of inclusion versus control. And control has a really a really powerful argument for it because you can move super fast. If we were only delivering software for Netflix, and this is what allows, I think, a lot of projects to go super fast in the early days, is you can focus on a narrow set of problems, a narrow set of people, and you don't really need to ask permission or you worry about what else breaks or something like that. But it's incredibly important to include other people in the community and not just give lip service to inclusion, but actually have other companies with other use cases and get more people involved, because you can't build something that actually becomes this widespread without it, without the early contributions of Jack from AWS or Anton from Apple or Russell also from Apple. I could just keep listing Apple people. Those contributions and the ideas from those communities are invaluable. They are what fuels the Iceberg community, and I think it's an incredibly important thing. So yes, we could move faster. We could build something and probably deliver it as maybe a commercial product incredibly quickly if we wanted to do that. But what we're going to miss out on is the ability to make it more widespread. And of course, I always talk about this. This goes to my own laziness, which is that I only wanted to build it into Spark. I wanted other engines to build. I wanted Upsolver to add support for it themselves, so I wouldn't have to. And that is the kind of thing that we get from truly inclusive open source. But that also, if you're not controlling, then you have a focus problem, because feature creep starts really, really quickly. And that's where we get to the next thing. How do we manage feature creep? Well, feature creep is actually a good thing. So I think one of the things, the next design principle in Iceberg was actually do hard things. Take on hard problems that no one had done before. We were literally ripping out the foundation of the Hadoop style data architecture, I guess. I shouldn't call it data warehouse. I think we did at the time, but we were ripping that out. And so we had to focus and actually take on hard problems like schema evolution, hard problems like when we're adding deletes into the format. How do we do that effectively so that we can have equality deletes for Upsolver and these use cases that don't want to read a whole bunch of data in order to delete rows? So how do we take on those hard problems? I think that we've done a really good job of that. Again, with a narrow focus, and other projects have more narrow focuses, you can, again, like simplify the problem, but it's not as applicable. And then, so both of those are sort of driving towards this, like, well, how do you choose what hard problems you solve? And, how do you choose from those, the large set of ideas that people are bringing to you? And for that, I think it really came down to our priority, which was humans and productivity versus machines and efficiency. I'm actually really happy about today, because this has been a theme throughout a lot of the talks where, like, DuckDB saying, hey, it's about how do we make people productive when they're asking questions of their data. And this is really something that I think guided the choices that we made in the format. How do we know what to work on? Because it's super easy to go like deep on vectorization. And we did go into vectorization, but we didn't do it until other things had already been fixed. So until we'd sort of gotten the big rocks out of the way. And I think that was really important for the format as a whole, because it set up the foundation of the format as something that really works for people. And I think that's sort of the main superpower of Iceberg compared to alternatives. So I have one last thought, which is sort of my own personal soapbox. Jack will recognize this because pretty much every PR runs into this. Don't use get and method names. I say this all the time, so that one's, very, very important to the Iceberg project as well. All right, so what we ended up building in retrospect, looking back on this is an open standard. That was there from the start. The fun thing that we rediscovered, and I mentioned this in the panel last hour, is just SQL behavior. we essentially rediscovered the SQL table abstraction because every time we went to solve one of those hard problems, it came back to, well, what do people already expect? Right. They expect SQL behavior. They expect these things to just work. So that is where we were. And I think that this really set up Iceberg for, the next level. And what happened was basically a happy accident. I think there's a point at which any successful technology um, exceeds the expectations of the people who initially created it. And Iceberg has certainly done that. I did not expect to be here in a room in New York with 100 people and like talks about Iceberg all day. That's pretty crazy. So thank you guys for being here. But let's talk about what happened after we built Iceberg. And this we also touched on, but I think what was surprising is that Iceberg solves a larger problem than just fixing tables. We set out to fix tables. We ended up rediscovering how important SQL is for that. But the background, like the thing that we didn't choose was that we were trying to integrate Hive and Pig and Trino and Presto and Spark and even Snowflake at the time on the same data sets. So this was an assumption of what we were doing. And we didn't realize that solving transactions and making it so that Spark can update a table without affecting your Trino query's correctness solves a larger problem, one that we hadn't actually solved before, which is shared database storage. So now all these engines can, it seems obvious we set out to make it safe for engines to share data sets, and we did. But that's actually a big thing. That's something that at least the analytics space hadn't done before. So it was very surprising when Snowflake and BigQuery and like these engines that I would consider from the warehouse world, that never went through this sort of adolescence of the Hadoop space and then needed to grow up. What happened over there? Like, why are they integrating Iceberg? Well, it turns out this is, I think, a classic disruption where you go and build something to solve a different problem, and then you find out, oh, it's valuable to people over here because of the flexibility that gets unlocked. Because now we can have ML and analytics sharing the same data. And that was quite surprising. But as we also touched on last hour, that's a really dangerous place to be. I really liked Yanni's summary of it, which is, you used to put all of your data in one place and then pay that vendor, and that was the only way you got data out. And the whole foundation or business model of the big data, or sorry, the data industry is built on that model. And now shared storage is changing that. And so, oh, I already covered that. I should have gone to this slide earlier. I'm sorry. That's what I think is the quiet revolution. So shared storage really fundamentally changes the game, I think in a positive way, because we can build a central storage platform that no longer requires copying, can be, where's Eric, secured, those sorts of things. But it really is going to be interesting how we get to that future state. And how we get to that future state is the subject of my third section, which is wild speculation or sketchy predictions. We'll go with sketchy predictions. All right. So, sketchy predictions about the future of the data industry. This should be fun in 5 years. All right. So, first of all, I think where we're headed from the data warehouse side of the world, the big SQL engines that have been, worked on very hard for a long time, those are splitting in two. This is the story of Snowflake and BigQuery and others adding support for Iceberg, because Adding support for Iceberg means that you can move who manages and where that storage is. You can share data sets. And everyone wants this. And it makes sense because there's so much data in our data lakes, right? Everyone wants to play in the data lake data. And it's cost prohibitive to put all of that into a data warehouse. So we've got this vast quantity of data, and they need to add the ability to access it and query it and win those workloads. But at the same time, that's sort of undermining this model of give us your data and then use our compute to use it, because you can put your data in and then use it through some other system. And that's kind of crazy. So we're separating the compute side of a data warehouse from the storage side of a data warehouse, because now we have a technology that can actually do that shared storage. So that's number one. Number two, what happens to the data lake side of the world? Well, I think that the adolescence, where childhood was Hadoop, adolescence is the data lake side. Data lake period, where we're all on object stores, but it's all really DIY. You've got to figure out, where's my catalog? How am I locking this down? I need that Ranger system to hold my policy, and then I've got to make sure that all my other things talk to that thing, and then I sync policy over here. Like it's an absolute mess still. And this is, I think, my disagreement with Yanni. Are we actually in a space where this is modular and flexible, but not just difficult to use and difficult to set up and own? So I think data lakes are going to continue to mature and become modular, where I'm defining modular as very composable. So like, do I have this slide in here? No. Okay. I'm going to skip to my modular slide. There we go. Modular architecture. So we need things that are composable, but that fit together naturally. Things like that just work like Legos. You can put any two Lego pieces together, right? You can build whatever you want and it just works. And we're not quite there today. What's going to get us there are more open standards, oddly enough. So Iceberg, an open standard, but the next, and this is where we get into the roadmap side, the next step is a protocol for interacting with catalogs, because Iceberg is a spec for a table in isolation. How do I modify and safely make changes to that table? When I'm looking at a collection of tables like a warehouse, well, what is running the catalog for that? How do I talk to that thing? And from the early days, Iceberg had the ability to plug in multiple catalogs, which helped us along, because Netflix could have their own, Apple could have their own, you could use the one from AWS, like everything was flexible here. But now we actually need to minimize choice and agree, like, well, if you're going to be able to support multiple catalogs, here's how you talk to all of them, not just a single one, because I'm never going to get a jar into some bespoke engine. Like you're not going to get a tabular jar into BigQuery, right? That would be incredibly difficult. So modularity and open standards like OAuth, REST spec, and all that really matter. So let's get back to predictions. So the thing about these two predictions, so warehouses split in two. Data lakes sort of consolidate and become less DIY and more modular. And I think that means those two sides of the world start to converge. And this is where the predictions get pretty crazy, because who knows what happens. But I think that we need a realignment, right? Instead of thinking of these two things as separate technologies and separate spaces, they're moving towards one another. And really what is going to matter about data architecture and how to think about this in the future is what is centralized and what is specialized. Because there are a lot of things that need to be centralized. Tables were evidently something that needed to be centralized, but we couldn't make progress until we had tables that actually worked. Now we can make progress, and we're running into all sorts of issues, like who runs my catalog? How do I talk to that catalog? Can everything talk to my catalog? No. So we actually need a REST catalog, right? What else is going in that centralized layer of what I think of as storage? Because storage is definitely a centralized component. We don't want to copy it. The specialized components are clearly compute. So, data warehouse compute, really highly specialized, very optimized processing engines, very specialized because are they doing, graph analytics like puppy graph? Are they doing streaming? Are they doing ETL and, data loading and ingest? Probably not. Like specialization is something that we want to encourage, and it's definitely a trend moving forward. So the question is just going to be, what is on the connect to my data warehouse side, the specialized, what compute do I want to use, and then what is centralized. So I think this actually helps me really clarify the space when I think about it. So when I was listening to Ben's what is a database talk from earlier today, I was just putting things in categories of like, oh, okay, well, that's a specialized component. So we're going to have multiple specialized components. We have storage, security, catalog, data services like compaction and things like that that all go in that centralized or common data plane. All right. Modularity is, this is why I had that slide later. Okay, so what's going to fuel this transition to centralized versus specialized is how we decide on that divide. And when we decide on whether it goes in the bottom half of the database, the centralized part, or the top half, the specialized parts, is going to depend on an open standard so that all of those specialized components can talk to the centralized ones. That is where modularity becomes incredibly important. Until all those things can talk to one another, we're going to be stuck syncing policy across 4 different database engines. Last, and Yanni stole the thunder for this, which I'm actually glad about. I think that when we're in this world of a centralized data layer, that independence of that layer is going to be critical. So if you have a whole bunch of these specialized compute products, which one do you trust to manage your data? And do you trust that one to manage your data in a way that is effective for all the other specialized components, all of the other compute that you're using on it? So I think the obvious thing here is like, say I have a graph engine. Do I want that graph engine choosing how to store the rest of the data in my common data plane? Probably not, because it's going to do wacky graph things. That's not great usability. Wacky graph things? Thank you. It's not going to be great usability for other people. And it's so easy to make choices about data that affect what the other engines can do. So I see storage as an area where you create opportunities for the engines to be efficient. And it's up to the engines to take advantage of those opportunities. So things like in Iceberg, we keep column level statistics, min-max values, so that you can quickly skip through files that you don't need if you have a filter on one of those columns. So say I'm looking for ID 5, and I know this data file has IDs 100 to 200. I don't need to read that data file. Well, that is information from the storage layer providing an opportunity to the query layer. And in that case, well, if I just don't give you those column stats, then you're going to be a bit slower, but that makes me look good. There are some real negative consequences of centralization. So I think it's going to be increasingly important that we think of these two things as separate systems, that storage is independent and independently managed, and also secured, because security is absolutely essential, especially in this age of AI spitting out things that you don't want it to. That's pretty critical. And that's pretty much it. That's my talk. If you want Trino and Spark cheat sheets, we've built some of those. We also have an Iceberg cookbook with a whole bunch of practical recipes for using Iceberg and learning more about it. So please visit those QR codes and reach out if you have any questions. We're not scary. I also just want to do one final plug, which is for Tabular. That's my company. So this is sort of the architecture that I'm thinking about and talking about a lot. Tabular sits off to the side and provides a lot of the functionality of those centralized components. So that's the vision. We're an independent and neutral storage platform. Thank you. Do we have time for questions? Do we have time for questions? All right, let's do questions.
So 2 layers, compute and storage, right?
Ish.
Yeah. So security, you suggest to be on the storage level.
Yeah.
So basically, Snowflake will have no, in the ideal world that you're proposing, Snowflake will have no EDL, no declaration of access rights.
So, okay, good question. The question was, okay, I have a storage layer and a compute layer. I'm saying that security needs to be at the storage layer, which I do agree with. So what does Snowflake do? Well, should it still have DDL? Should it still, I think the way that people interact with that security layer probably doesn't change. You still want to be able to, add users or create roles or manage grants and things like that. I think that is one thing that should probably be everywhere. But what holds that policy, what enforces it, needs to be at the storage layer so that things like a Python process that comes in, needs an identity and can access data that is, allowed for that identity. I think the other aspect there is you're never going to get away from storage engines being a part of security. So the REST catalog, and we're working with AWS on this, is going to be able to provide security decisions. So like, okay, you came in and loaded this table as user A. User A can read columns B and C, not column A. And so the engine is responsible for, if it is trusted, for applying that policy, that security decision. But we don't want to just blanket share policy everywhere because that becomes a mess.
So like call back to the catalog will be called back.
Exactly. Whatever you're using to load that table, right? Get its catalog information. I think that component provides like, well, here's what you can read from that table. Any other questions? All right. Thank you, guys. I know it's late. I appreciate you listening.